right, turn in your speed drill and review exercise booklets to page 28. Speed drill and review exercise booklets to page 28. We're going to do a 2-minute speed drill, adding some numbers together, working an addition box. Now, some of these are going to be easier than others, so pick and choose the easiest columns or perhaps the easiest row or rows to complete it, but you will have 2 minutes.
We have one more.
What?
We only have one more after this, right?
Yeah, I think that's right. I think there's only one more speed drill after this, so do really well on this one. 2 minutes for this addition box, and you may begin. Stop. I actually gave you an extra 30 seconds on this one because I saw you weren't done just yet. Go and put your pencils away and take out a pen. Pencils away and take out a pen. And let's see how we did. Pencils away, pens out, and let's see how we did. Looks like the streak of hundreds is over, but could still be a good score for you. Because they are just 2 points apiece. 2 points apiece. All right, going across the top row, your answers should be 37, 41, 90, 29, 33, 25, 53, 27, 82, 39. If you would write the total number incorrect on that top row, hopefully minus 0, put that off to the side. Then the next row, this is where I would have started, is the row with the 3, okay? Because it doesn't get any easier than this. Adding 3 to stuff. 22, 26, 75, 14, 18, 10, 38, 12, 67, 24. Okay, that row is probably the easiest row. Now, the next row I would have done is the bottom row. Why? Why would I have done the bottom row next?
It's so easy.
Why? What makes it so easy?
Because there's like one.
You've already done a row of 18, right? And this is a 17. If you just took 1 away from every answer in the top row, assuming your top row was good, Your bottom row could have been done in seconds.
Oh.
That's where a mathematician is lazy, finding things like that. However, I'm going to give you the answers to the third row. All right, the 41. Adding 41 to everything. Here we go. 60, 64, 113, 52, 56, 48, 76, 50, 105, 62. Now, the next row is 103. You already did a row of 3, right? So if you stick a 1 on the beginning of every number, add 100 to everything in the second row, you have the fourth row. 122, 126, 175, 114, 118, 110, 138, 112, 167, 124. Mathematicians are lazy. We find these things. And then the bottom row, again, will be 1 less than everything that was on the top row. 36, 40, 89, 28, 32, 24, 52, 26, 81, and 38. All right, figure the total number incorrect, multiply by 2, subtract from 100, and put the score on the score page where it says speed drill 26, the next to last blank on that page. So 2 points each. Figure the score. Did you learn something today? If you did, then it was worth it to miss a few if you learned to watch for things like that. Always look for shortcuts. That said, how'd we do?
Yeah, I got 88.
88's not bad. High B, B plus. How about you, Josh? 70 flat. Oh, we held out passing, all right. You've done better on some of the other ones. That'll help kind of boost that grade up. All right, but do you see now how you could have done it very, very quickly and accurately? So, yeah, live and learn. Live and learn. But not if you used the shortcuts I gave you.
I didn't see that.
Nah, you gotta see them. And that's okay, we'll see them moving forward. Turn to page 523 in your textbooks. Page 523 in your textbooks. And right at the end of the hour yesterday, page 523, Lana, right at the end of the hour yesterday, we were talking a little bit about triangles. It'd been a while since we'd talked about those. Wanted to review some triangle concepts. And one of the facts we said is that the 3 angles of a triangle always add up to 180 degrees. So go ahead and do page 523, number 23, A, B, and C, where they've given you 2 angles. You need to find the third angle. Take just a few minutes, maybe a minute, minute and a half. Maybe finish all 3 parts to number 23. And Glenn and Hayden back there during the speech are like, oh, I know what I need to do next year. Page 523, number 23, parts A, B, and C. Let's see how we did on these. Letter A. If you have an 81 degree angle and a 12 degree angle, the third angle must be, Joshua? 87 degrees. Lana, if we have a 138 degree angle and a 19 degree angle, the third angle's got to be? 23 degrees. If you have a 57 degree angle and a 60 degree angle, the third angle must be, Joshua?
60 degrees.
Good. What kind of triangles would A and C be?
Acute.
Acute triangles, because all triangles are acute, whereas triangle B would end up being an obtuse triangle. 138-degree angle would give you an obtuse angle in there. So would be an obtuse triangle. No. The three angles are 81, 12, and 87. Those are all acute. For letter B, it was 138, 19, and 23. Well, one of those is obtuse. It's an obtuse triangle. And letter C was 57, 60, and 63. Does that make sense now? Yeah, looking at all three angles there. Turn the page. Turn the page, and let's talk a little bit more geometry here. Number 18 it says, give the specific name for the type of quadrilateral that fits each description. What is a quadrilateral, Lana? Four-side thing. Okay, four-sided polygon. What about a quadrilateral whose opposite sides are parallel? Too specific.
Square.
As long as the sides are parallel.
Rhombus.
Parallelogram. Go and write that down. Go and write that down. Parallelogram. So to give you the word parallel, just write an O-gram at the end of it. All right, letter B. A rectangle with all sides equal is a square. Good. How about a parallelogram with all sides equal?
Rhombus.
A rhombus. Very good. A rhombus, R-H-O-M-B-U-S. Number 9, a parallelogram with 4 right angles. That's a rectangle. A rectangle has the 4 right angles. And a quadrilateral that has only one set of parallel sides. That is a trapezoid. Very good. Number 19, they give you a triangle, and that angle X, remember, is called an exterior angle because it's outside the triangle, correct? There's 2 ways you could find angle X. Lana?
Don't you add both of them up and then subtract one of them, right?
Joshua, can you help her? Or have you forgotten also?
Do you just add them?
Right. Remember, an exterior angle X always equals the sum of the other 2 angles. Now, we could, though, Lana, add those 2 angles, subtract from 180, and get the third blue angle right next to X. And then we could say, well, the third blue angle and X are next to each other along a straight line, so they would add up to a straight angle, and subtract from 180 again. But it's easier just to add the 2 opposite interior angles. So, how big is angle X?
156.
Good, 156 degrees. So some triangle review there, some things we hadn't talked about for quite some time. Questions on that? All right, look across the page 525 now. Page 525, and I want you to do numbers 1 through 6 at the bottom of the page, asking yes or no, are these like radicals, and if so, add them. Are these like radicals, and if so, add them. If not, you can't add them anyway. 1 through 6 at the bottom of page 525. Number 1, are those similar radicals or like radicals? Lana?
Yes.
Yes, because they have the same index and the same radicand, so we can add them to get
5 times the square root of 3.
good. 5 times the square root of 3. Number 2, Joshua, are those similar radicals?
Yes.
Yes, then we can add them and get
8 times the square root of 14.
good. 8 times the square root of 14. Number 3, Lana, are those like radicals?
No.
No. They do have the same index, so you could multiply those things together. By the way, what would you get if you multiplied those, either of you? If that were a multiplication symbol instead of an addition sign.
25 times the cube root of 10.
Good, 25 times the cube root of 10. But we're not multiplying, we're trying to add, and they don't add, so we're done. How about number 7, Joshua? Are those like radicals? No, so we can't add them either.
I thought it's yes, because you could do a times the square root of 7a.
Careful. You're right, 2 goes into 2 one time. But is there any left over? 2 goes into 2 one time with nothing left. So you're right, you could reduce the square root of 7a squared, but that would be a times the square root of 7, which doesn't add to the square root of 7a. Now they're not like radicals anymore. Does that make sense? Yeah, so careful there. No, they don't add. How about number 5, Lana?
No.
Nope, one's a square root, one's a cube root. They couldn't even multiply. How about number 6, Joshua?
Yes.
They are? One's a square root of 12. The other's a square root of 27. They don't look similar to me.
Well, you have to factor.
Right, you've got to reduce them first, and they do simplify. The square root of 12 ends up becoming
2 times the square root of 3.
right, you factor 4 times 3 to get 2 times the square root of 3, and then the 27 becomes
3 times the square root of 3.
right, factor 9 times 3 to get 3 times the square root of 3, and so our answer should come to
5 times the square root of 3.
5 times the square root of 3. Great job there. Questions on those?
That doesn't make sense.
What do you mean doesn't make sense?
How do you get 3 times the square root of 3?
Well, it factors into 9 times 3, right? And then we take the square root of 9 to get 3, and we leave the square root of the other 3. Just as this was factoring into 4 times 3, and that's where the 2 came from. Does that make sense?
So it's 5 times?
So 5 times the square root of 3 is our final answer. Questions on that? Let's see. Do we have? Yeah, we have some more coming up. Let's do another round of these, and if we need to, we'll do some more as well. Go ahead and do number 7 through 11 at the top of the next page. Go ahead and do 7 through 11 now at the top of the next page. If we need to after 7 through 11, we're still a little bit iffy on this. We'll do some more.
This is a little more fun.
just a little bit longer to be working on these 5 problems. Let's go and take a look at numbers 11, or 7 through 11. Number 7, are those similar radicals, Lana?
Yes.
Yes, they are. We look at them, and I always would start with the easiest looking radical, which is the 15. And I try to factor it, but the only way to factor 15 is 3 and 5. Neither of those are squares. It doesn't simplify. So then we look at the 60, and we're like, well, the only way this is going to help is if somehow the 60 factors into 15 times a square, and it does. It factors into 15 times 4, so that's going to simplify down to give me
2 times the square root of 15.
Right, 2 times the square root of 15. Of course, we'll keep the 6 times the square root of 15 and add them to get
8 times the square root of 15.
8 times the square root of 15. Do we get that, Joshua, on number 7? Does it make sense now? Does it make sense how to think it through so it doesn't become too hard? Again, 15 doesn't do anything, so I've got to be left with a 15 for this to really work out. Ah, it does come out with a 15. Let's take a look at number 8. And Joshua, are these similar radicals? No. Now, the 44 does factor, though, into
11 times 4.
where I take the square root of the, well,
I meant 4.
to get a
2.
times the negative 6 gives me
Negative 12.
times the square root of
11.
11. And this factors into 11 times 3, but you can't take the square root of 3. You can take the square root of 4, but not 3. So really, it just doesn't do anything, and these are not similar radicals, and so we can't add them. No, they are not similar. Lana, number 9. Are these similar radicals?
No.
No. Now, there is some simplification I suppose we could do if we wanted to. For practice sake, let's review. I could factor, Lana, the 24 into...
8 and 3.
Now, for a square root, we want 4 and 6. But it's not a square, it's a cube root, so we want 8 and 3. Where we would take the cube root of the...
8.
to get...
2 times the cube root of 3.
And then when we worry about the letter, we're asking ourselves, how many times does this go into that? And 3 goes into 4
1. So
with...
1 left.
Well, the next one, the cube root of 8a squared, well, I don't need to factor the 8. I've already got it. It's right there. Just take the cube root of 8 to get 2. But does 3 go into 2?
No.
No. So I'm left with a 2 times the cube root of a squared. Obviously, these are not similar radicals. You can't add them. You could do a little simplification, but they don't add. What about number 10, Josh? Were those similar?
No.
Wait a second. Oh, that's dirty. At first I'm like, there's not even the same indexes. But they turn out not to be radicals at all, do they? Look for a moment at just the first one, Josh. Can you take the square root of 9?
No. Wait, yes. Yeah, 3. My bad.
And 2 goes into 2 once evenly. You could take the square root of 9x squared and just get plain old rational.
2. Wait, no.
Square root of 9 is what again?
3.
3x, which gives us, when we multiply by 6, 18x. Then we look at the 4 times the cube root of 27x cubed. Well, same kind of thing. I can take the cube root of 27. That's rational.
3.
And I can take the cube root of x cubed.
X.
And I can multiply 4x and 3x to get
12x.
12x. And now they are similar radicals because they just ain't no radicals. So the fact that there aren't any makes them similar, and now I can add them to get
30x.
30x.
Wow.
So yeah, they actually gave you rational radicals, one a square root, one a cube root, but again, if you simplify, you realize these actually don't even stay radicals at all, so yeah, I guess I can add them together. Let's go back to you on number 11, Josh, because number 10 was interesting. Make you pay attention, I guess, if nothing else. But this next one's a little bit more like what we'll see on quizzes and tests. We've got the square root of 72y to the 5th plus the square root of 18y to the 5th. And are these similar?
I put no.
They don't look similar, that's for sure. But maybe there's some reducing we can do. Let's take the easy one first, Joshua. Which one's easier?
18.
Right, and how might we factor the 18?
9 times 2, that's what I did.
Where I'll take the square root of the
9.
to get,
30.
and let's just leave the square root of the 2 for now. Now let's also take care of the letter though. Divide exponent by index. 2 goes into 5
2.
with,
1.
now Joshua, for this to work out, this has to have a 2y left in it, because that's what's left here. Let's see what happens, Joshua, if I try to factor this into 2y times something. What would have to be multiplied by 2y to get 72y to the 5th? In other words, divide by 2y.
I know it has to
2 goes into 7.
Oh, is it 36?
And y to the 5th divided by y is?
Y squared. Wait, no.
Y to the 4th, right? We're just dividing. 72y to the 5th divided by 2y is 36y to the 4th. And guess what? I can take the square root of that. What's the square root of that?
6y squared.
And then we're going to leave the square root of the,
2.
and sure enough, they're similar radicals. What do we get when we add them?
9y squared times the square root of 2y.
9y squared times the square root of 2y.
This is...
Questions on this? But do you see how, Joshua, you can use the easy one to help you figure out what to do on the harder one? Does that make sense?
I almost had it.
Let me give you a couple more. I know these aren't in the textbook. I'm going to make up a couple just to make sure we really have this before we move on. Yes, ma'am.
I had it all the way right, except I forgot. I had 9 times the square root of 2y to the 5th.
Okay, you never dealt with the y. You left the y to the 5ths in there. Let me give this to you. How about the let's do the square root of 54ax cubed plus 2 times the square root of 96. Let's make that a 2x times the square root of 96ax. Take a moment to work this. Simplify both radicals and see if you can. Did you simplify the first radical correctly?
Oh, I worked on the second one.
Oh, you started with the second one? Oh, the first one's easier. Little number. Always start easy. If you get the easy one, and you factor it up, and you're left with a 6ax, then you might try to factor this into 6ax times something. 6ax times what, class?
Well, wait, what?
6ax times what?
36.
What's 96 divided by 6?
I did it a different way.
Ah, that's part of the problem. What's 96 divided by 6?
Something with a 1 at the end.
16.
Oh.
Ah, and that's a square. And we can take the square root of 16, class, to get 4, but we already had a 2x here. So it's 4 times 2x to get 8x times the square root of 6ax, and lo and behold, similar radicals, we could add them, Lana, to get
11x squared.
not 11x squared. 3x plus 8x is just 11x.
And the square root of 6ax.
There we go. Now, Lana, if you started with 4 times 24 to get 2 times the square root of 24ax, you didn't finish all the way.
I kept going.
Because there's another 4 in here, right? 4 times 6. Well, excuse me, there was a 2x out here too. ax, and you pull out another 2, and now it's 2 times 2x times 2 gives us 8x times 6ax. Well, sure enough, you do a 6ax here, that's going to leave you with a 9x squared, which gives you the 3x. But I always start with the easiest possible radical. Let's do one more of these before we move on. Question?
I got 4 times the square root of 6ax. When I reduced
There was an 8x, there's a 2x at the beginning.
Yeah, you just multiply by the 4 that I got from the 96.
To get 8x.
Yeah.
Times the square root of 6ax.
But why would you multiply the 4 though? Like by that?
Okay, let me try this again,
Multiply
Lana.
4.
You said you ended up with a 16 times 6ax, correct? And that's where you ended up with a 4 times the square root of 6ax times the 2x.
Oh.
It's still there. You just multiply all of it. And that's where we get 8x times the square root of 6ax. Does that make sense now?
Yeah.
Let's do another one.
Because I didn't know you had to multiply those. I thought you had to add them together.
No, you add each term to the other term, but within a term, everything's being multiplied. It's 2 times x times the square root of 96ax. Everything's being multiplied within a term. All right, let's do the square root of 180 plus the square root of 20 minus the square root of 45.
What? We've never done. Okay.
And always start with the easy one. Which means don't start with the 180.
I started with 185.
It's called disobedience, Lana.
What is that? I heard you, but then my brain just. Okay.
In one ear and out the other. It's a shame, isn't it, Glenn? Shame, shame. You won't be that way next year, will you, Glenn? course not.
Now you're picking on me.
That's funny.
So which one should we start with, Lana? Good choice, Glenn. 20. Let's start with 20. How would we factor 20, Lana?
3 times the square root of 5.
I'm sorry?
3 times the square root of 5.
Good. 4 times 5, which gives us 2 times the square root of 5. Right? Now, Lana, if that's a 5, what number do we really want to see in the 45? A 5. And it is 5 times
15.
5 times 15 equals 45?
No, 13.
9. 9 times 5 is 45. All right, now, hey, calm down, okay? So, Lana, that means, how does this fully reduce?
3 times the square root of 5. I was trying to get to the final answer.
All right, now, don't do that, Lana, because nice, slow and easy here. All right, so, if that has a 5 and that has a 5, then we really hope this has a 5, right? So, Lana, we're going to ignore trying to think of what root is here. We just want 5, right? 5 times... 5 is in...
6.
All right, 36. Ah, that becomes...
6 times the square root of 5.
And now we can add and subtract. And what do we get?
Oh. 1 times the square root of 5.
6 plus 2 is?
Okay.
Minus 3 is?
5
Times the square root of 5.
Yeah,
Get some
you're
sleep
right.
tonight, Lana. Get some sleep tonight. You're
I'm
smarter
not
than
so
this. You know this so much better
I
than you're
know
thinking.
already.
You got it. Good job, Joshua. Good Joshua.
Well, if you
man.
did it 20 times 9, would you have gotten the same answer? For the
Well, I mean, you would have eventually gotten there, but then you would have had to factor the
Yeah.
20 down. So that's why you start with the easy one and use that to help you with the hard
Why
ones.
did I not realize 9 times 5?
I don't know.
All right, let's move on. We need a break from this. So let's go on to the next section, your pure quadratic equations. These should be a breath of fresh air for you. Let's do the odd problems 13 to 23. Let's do 13 to 23, the odd pure quadratic equations, here on page 526. But we want to get the square variable by itself and then take the square root. So page 526. 13 to 23, the odd, solving these pure quadratic equations. Take it easy there, Laura.
What?
Take it easy on your book there. Wham, wham, wham. Taking out her pent-up frustration and fury on the book. I guess it's safer on the book than on, Glenn.
Why would I hurt Glenn?
I don't know, because he's Glenn. Why not? She's like, why would I hurt Glenn? I don't know, why not? I don't really hate you, Glenn. Not deep down. Seems like I do.
Why don't you ever pick on him? On Hayden?
Glenn's more fun.
He's got his turn from next year.
I'm sure I will next year.
You
Bring it up. Let's go.
and check the first few answers. I didn't have room to put them all up there, but you should all at least be done with 13, 15, 17 by now. Did everyone on number 13 get positive, negative 15? On number 15, did y'all get positive, negative 4? And on number 17, positive, negative 10? All right, finish working the odds. I'm going to go ahead and erase those first 3 to make room for number 23 because I couldn't fit that on the front board. Hopefully Scott did. If not Scott, let me know. If you finish early, go on and do the evens. I will run through the answers to the evens very quickly here in a moment. For now, finishing the odds. Want to good to go on 19, 21, 23? I could go on and do the evens. Number 23. Oh, you did right here. These are not like terms. They don't combine. Right, that's a 2m squared, that's just a 28. So they don't combine to get a 30m squared. But, if this were a, you could actually take the square root of that. Square root of 4 is 2, square root of 9 is 3, so it actually would have worked out to probably negative 2/3 if that had been a 28m squared. For sake of time, Joshua, just check up here. Obviously, we wouldn't combine, we'd leave them. So then we've got the little ones over here. We'll subtract it over here to get m squared. Plus 12 equals 28. Subtract away the 12 to get 16. Take square root positive negative 4. All right, go ahead and do the evens. See how far you can get in about a minute and a half. See how many you can get done. Well, it's like Scott's already done all the evens. Good job, Scott. Excuse you. Go ahead and stop where you're at. I'm going to give the answers to all the evens, but obviously the only ones you care about are the ones you got to. Number 12, x is positive negative 8. Number 14, b is positive negative 9. Number 16, h is positive negative 5. Number 18, d is positive negative 7. Number 20, r equals positive negative 1. And if you made it all the way to 22, z is positive negative 6 times the square root of 2. Positive negative 6 times the square root of 2. Of the ones you did, were there any you missed that you want to see worked out in the last, 20 seconds of class? You're good to go? You're good to go. All right, homework for this evening is to do page 526, numbers 1 to 12. Page 526, numbers 1 through 12. And for homework, you'll be practicing over the things we did in class today one last time in anticipation of a quiz tomorrow. So make sure we've got it figured out in the homework. All right, have a wonderful rest of your day, and you'll be dismissed when the bell rings.